If you're learning about dimensional analysis, you have to learn first what is a conversion factor. But trust me on this, you already know what they are. So, for example, you know that 1 hour is equal to 60 minutes, or 60 minutes is equal to 1 hour. You already know that 1 week is equal to 7 days, or 60 seconds is equal to 1 minute, or 12 inches is equal to 1 foot, or maybe you know that 1 meter is equal to 100 centimeters, or 1 inch is equal to 2.54 centimeters. Okay, you might not know that one if you're just starting out, but these are all examples of conversion factors. Notice that you have the same amount of stuff, except you have different units, different values, but the amount is the same. 60 minutes is equal to 1 hour. Even though the units are different and the numbers are different, that's what makes it a conversion factor. So let's jump right into an example and you'll see how easy dimensional analysis truly is. One last thing though, when it comes to conversion factors, you'll either know them or you will learn them. You will only be expected to do dimensional analysis and to do work with numbers that you either have access to in your head or on the paper or something you'll expect it to learn in the class. So here's a really simple example. How many minutes is 2.5 hours? Now in your brain you might do, okay, 1 hour is 60, so add another 60 and then add half of 60. But here's the systematic way to use dimensional analysis to do problems like this, and especially when they get more expansive and less likely to be done in your head. So what I like to do is I'll take the one thing I know, I got 2.5 hours, and I'll put that over 1. Then I put a multiplication symbol and a fraction bar. I'm just setting things up right now. I look at my units, hours in this case, and I put that in the denominator because it's in the numerator over there. That means they're going to cancel out. Put your units down first. That's a big, big tip. I'm not even going to say that I do it and maybe you should do it. You should definitely just do it. You don't have to put the S, by the way. Whether something is plural or not depends on the situation. It really doesn't matter. So hours, and then I'm going to go straight from hours to minutes. This section right here is where I'm going to use a conversion factor because we actually have one. So let's put the numbers in correctly. You can say it like a sentence. 60 minutes is equal to 1 hour. That's the correct way you would put those numbers in. But a common mistake is people having the right units, but they put the numbers in upside down. So they might put like the 60 here and the 1 here. But then you got to just ask, does it make sense that 1 minute is equal to 60 hours? Of course not. So you're going to put 60 minutes, 1 hour. Look at your units and make sure they cancel. Hours cancel on the top and the bottom. What I like to do to tell me that I don't need to go any further with any additional conversion factors is I circle the unit that I'm asked for. I'm asked for minutes. Minutes is the only unit that didn't get canceled. Then I'm going to do my math, and it's going to be 2.5 times 60 divided by 1 times 1. But since 1 times 1 and all that is just 1, 2.5 times 60 is the math I'm going to do here. So that's going to be 150 minutes. And that's going to be my answer. That's how you do it with dimensional analysis. It's a lot faster once you get the hang of it, but that's the gist. Let's do another example. We're asked, how many feet is 370 centimeters? So let's start with what we know here, which is 370 centimeters. I put that over 1. Anything over 1 is itself. I'm just setting up the units. Put your units down first. We want centimeters to go. It's got to go in the bottom if it's over there in the top. And I'm going to go from centimeters to... It might be tempting to go right from the starting unit to the next one, but that only works if you know the conversion factor that directly links the two. In our list here, we don't have a conversion factor that directly links feet and centimeters, so sometimes you'll have to go through multiple conversion factors. In this case, you will have to do that. So we're not going to go from centimeters to feet. We're going to go from centimeters to inches because we do have a conversion factor there. And then we're going to cancel out our units, so I can do that here without putting any numbers in. I like to put my units in before my numbers. So centimeters are gone. If I stopped this question here, I would just be converting to inches. We got to go one more step. So since inches is not killed yet, we can put that in the denominator and then go from inches to feet, get rid of inches and feet, just get rid of inches, circle feet, and that tells me that my problem is going in the right direction. Centimeters cancels, inches cancel, feet do not. So let's actually put in the numbers for our conversion factor carefully. So if we look at the inches and centimeters, we have one right here. We know that 1 inch is equal to 2.54 centimeters. Cool. What about feet and inches? We have a conversion factor right here that says that 1 foot is equal to 12 inches. Everything is in the right place. At this point, it's just the math. So when you do this, you're going to get a number. It's going to be about approximately 12.1 feet. And that's how dimensional analysis works. Those are 2 simple examples to get you started. The main takeaway is make sure you have your conversion factors ready. They'll either be in your head or you will have learned them in class or you can access them. And then Once you have your conversion factors, make sure that you put the numbers in the right place in your conversion factor setup for your dimensional analysis, and you'll get to the right place. Cancel out units that die, top and bottom. Circle units that you don't want to die, because that's what we did here. We wanted to know centimeters to feet, so centimeters went to inches because that was something we had available to us, and then inches went to feet.